Hey guys, welcome back. Today is day 86 of Codeforces Every Day until GM. Sorry if I sound a little different. My throat is feeling a little raspy today. I don't know if I'm sick or what. I did wake up to the AC blasting at me today, so yeah, I don't know. I've been kind of feeling under the weather all day. It's been rainy and stuff lately too. Maybe I caught something. Who knows? But yeah, I mean, yesterday I was recording a video. I did a interesting 1400 rated problem. This one right here, I believe, and I liked it a lot. It was an interesting problem. Too bad I forgot to press record though, so y'all didn't get that video. A little bit unfortunate. I might make like a separate video on this question because it was a graph problem. We don't do much of those on here, so yeah, go try this out. I also made it the problem of the day on the Discord. I think was it for yesterday or the day before? It's on the 8th, so yeah, yesterday. um but yeah, try this one out, tell me how it goes. I'll make a video on it later. All right, today, further dabbling into the 1400 rated, just pushing the pace as much as I can. Let's do strong password. Python binary search greedy strings. That's more of what I'm used to. Okay, our input is t equals int input. We take in an s for blank in range t. S equals int input. Second line contains, so first it contains a string, so s equals input. Second line is m, a single integer, m equals int input. And then our third line contains a string L, so it's a string, but it's an integer. Third line contains a string. Okay, so it is a string. L, and then fourth line R, something like this. Alright, what do we have to do? Monocarp finally got the courage to register on Force Coders. He came up with a handle, but is still thinking about the password. He wants his password to be as strong as possible, came up with the criteria. Password should be exactly m long, only consists from 0 to 9, should not appear in the password database as a subsequence. Okay. Also came up with two strings of length m, L and R, both consisting only of digits from 0 to 9. Wants the ith digit of the password to be between L and R inclusive. Does there exist a password that fits the criteria? Okay, so the first line is a string. That's a password database. Second line contains an integer, the required length. Third line, lower restriction. Fourth line is okay. Okay, it's a pretty simple problem, or at least like I understand what it's asking me to do. Now, is the solution easy? I do not know. My initial thinking is, of course, brute force. We look at this first test case. Subsequence. So, yes. The first, you can choose 50 as it doesn't appear in S as a subsequence. So, subsequence, if I remember correctly, is subsequence any order, or is it just like a substring? Just Google it to confirm real quick. Sequence derived by another sequence. So yeah, it doesn't have to be adjacent to right, but can it go like backwards? Like I don't think it can, right? Like we can't do 5-0 like this because O's don't come after the 5s and our minimum bound is 50. 50 should just be a possible answer, so it should be yes, right? In the second test case, um, all of them appear in, okay. It seems like the first check is if the length fits between the bounds, right? So we need to check. So we can check this case pretty easily. If len L and len R, and these need to be equal to. If it is, then we're good. Else print no. So what's our logic in here? Can I just do if not, print no, continue? Ugh. Are there any cases like that? I don't think so. Can't even check it. But I guess I can invent my own case, like one, uh, two, one. Yeah, okay. And if I did like 4, if I did 3, then it would work. Okay. Now, how do I think about this? So many numbers. Like, my brute force thinking is you just start from the lowest. I guess you can't. Would you find the first instance? No, that's too slow. Maybe some sort of pre-computation, like create all subsequences and then just pass. But then creating an array of all subsequences in itself will take a long time, no? It's like O to the n times 2 to the n. It's way too slow, right? Binary search, okay. So it's very obvious what our binary search bounds are. It's just L and R. Then it's DP greedy. DP is probably used for the subsequence case. Just can't really think of how we can use it here. So if I'm told to check 50 in this, what would I do? I would look for the first 5, then I would look for 0. That is O to the n time complexity. But then I need to check the next number, which means, so it becomes n squared. So I think this becomes like an n log n problem. Is n log n fast enough? 2 seconds. Maybe we just implement in C, because like I think this is like an intuitive enough solution. But it seems kind of simple though. Maybe it's too simple for it to be a solution, but we can try. So what I'm thinking is we have this string, right? This is our S, and then we, well, we can bound, oh, L and R are bounded by M. So we don't even need this check, probably, right? All combinations of 3 digits, each of them being from 1 to 4, fit the criteria. I should probably look at these test cases. Okay, I don't need this check because it's bounded by, like, L and R are like bounded by M already. So, what is it saying? If we get like one, if we choose 111, there's 4. Okay, I think my strategy still will work. So, let's say I have the string and then I have like, let's put X right here and then S right here or something. And then we have our number to check, SS. What we will do is whenever, so our checking logic will be, we first looking for X, not X, not X, X found. So now we look for S, not S, not S, S found. If we found, then it passes, or then it's in the database, which means it fails. So each time you're doing this, you're checking something. It's a 1 pass, which is an O of n, time complexity. Now to actually search for which number to use, I mean, worst case, it's O of n. Maybe we binary search. Does binary search even help here? Like, I'm thinking if we had like a range of 50 to, what's it, 56, and we start from the middle, how do we know which side to go, right? Because binary search would calculate the mid, which is 53. 53 would fail, so how do we know which way to go? Hmm. That's the question. If we can figure out which way to go, it becomes O of n, it becomes O of n log n. But right now, if we can't, if we just try every number, it becomes O of n squared, which is definitely too slow, right? Um, hmm. Let me take the middle. First instance of 5. First instance of 3. It fails. Now what? Five, three. Hmm. 5. Okay, I'm not really sure. I'm not really sure where to go right now. Um, let's just implement the brute force for now, and then maybe we'll get some insights. Subsequence checker. We take in a number and we take in a thing to compare it to for I in range len n. Wait, how does this work? We iterate through s. Wait, just to check the subsequence, it's in squared. It depends on the length. It's like len. It's len n times len s. That's not good. This shit's too slow. Okay, so I've been avoiding the DP. But maybe we can use like prefix arrays or something. Hmm. Say we had a simple case. And like, let's make L equals 12. Or equal like 34 or something random. Wait. What if I had 13 and like 22? No, it's all tens. Okay, so here's something. Wait. M. The third line contains a string. Oh, wait. Two strings are linked. So each. He wants the ith digit of his password to between LI and RI. Oh. Okay, so this is not possible. So if it's like 1, 2, 3, 4, that means the range for his first digit is 1 to 3. The range for his second digit is 2 to 4. Um, And then we have this restriction li. Okay, okay, that was confusing me. All right, all right. This makes it a little bit simpler, I think, because then what this means is we can create every combination of numbers, right? Well, okay, maybe it doesn't make it easier. How big can M be? M is 10. Okay, so not too bad. I think the worst case is right 10 ones, 10 nines, and you can match every single. But can we use zeros? Yes, we can. The lower restriction on each digit. Well, either way, what the thinking is from, at least for this case, our first digit can be from 1 through 3, so it's like 1, 2, 3. Our second digit can be from 2 to 4, so 2, 2, 2, 3, 3, 3, 4, 4, 4. These are all our possible combinations, right? So what we should do is say I had 1, 2, 3, 4, 5, 6. This case up here. We should uh we should do 2, 3. There we go. We should wait a minute. Shouldn't we always take like the last case? Because well no. 34 exists. But hmm. It'd be 3-2 in this case. One, two, three, 4, 5, 6. Okay, wait, I think I get it. So, okay, so given 1, 2, 3, 4, 5, 6, our first is like our allowed numbers are 1, 2, and 3, right? We should just greedily take the furthest number, which is 3. We can do this with like a for loop or something. And then, so we're saying our first number, our first digit should be 3. And let's move that to like here. First number should be 3. And then for our next choice, we're allowed numbers 2, 3, 4, right? We'll look at this. We take the furthest. So 2 doesn't exist, 3 doesn't exist. 4 does exist, so 4 is eliminated. We just pick the first one that doesn't exist. And if there's one that doesn't exist, it's we print yes, right? I mean, this makes sense in my head, but like, how do is this it? How do we code this? Also, this seems like some sort of combinations BS. Like, okay, we need our worst case is 10 digits, right? 10 available digits. Well, hmm. So we just create some sort of lookup table, I think. Okay. Maybe we make like a 2D array. Next equals -1 for doesn't exist. Okay, so this should, or in, we take it in? No, we know it's M, right? Wait, no, N should be the length of the string, it's len s. It's never given to us, so we just have to do len s. Right. So what this should output is an array, a 2D array of -1s. Oh my god, this looks so messy. Let's just isolate a case. It still looks messy. Um, 0, 1, 2, 3, 4, 6, 2, 1, 2, 2, 4. I want to. Yeah, this is 2, 4. Because I fucked up. This should be 2. Oh no, this is 3. So 1, 2, 3, 4. Okay. So the length of the string is 6 plus 1 is 7. So I should have 7. 1, 2, 3, 4, 5, 6, 7. Okay. So, and the 7th one should just be when the string like runs out. Yes, and then there should be 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 0 through 9. That's correct. Now we just need to fill this in. Right. For I in range. So what this should be is something like this, and then we have 1, 2, 3, 4, 5, 6. And, okay, imagine all these rows are filled with negative ones initially. Alright, I'm not gonna write that out. So we have 1, 2, 3, 4, 5, 6. We should start from I'm missing one. It should be 7. Like this. And then this row should just all be -1. Because this is when the string is finished. One, 2, 3, 4, 5, 6, 7, 9, 10. Alright. And then here we should do six. Row 5 would be here's next position 5 and all these are -1. These will be -1, like all these will be -1. Right? Because they never exist. So then it should be four. No, it's all these are 5s down the line. And then it's 4 here down the line. And it's 3 here down the line. 2 here on the line. 1 here down the line. 0. And zeros don't exist. These are all -1s. -1 down the line. -1s, -1s, -1s. Something like this. Okay, so this case is pretty. It's a bad example, Loki. I think because I think it's gonna look different. It's gonna look different if you have a repeating number. Maybe let's do like 1 2 1 3 1 2 or something, where we repeat something a lot. Uh, 3, and then we're gonna have 4 blah blah blah. But all these are -1 anyway. -1 down the line, and then for here it has 0 1 2 3. It's 1 2 3 4 5 6. 2 3 4 5 plus 1 is 6. And then down the line, this is -1 down the line. And then to fill this out, just becomes 0. Okay, 0 is -1 down the line as well. 1. Okay, so start from the back, right? 5. We have 2 at position 5, and then nothing else. The next is 1. 1 at position 4, 2 at position 5, nothing else. And then 3 at position 3, 5 4, then 1. Wait, this is correct. 5 4, and then 1 at position 2, 5 3, and then 2 at position 1, 2, 2, 3, and then 1 at position 0. So it's, wait, 2 at position 1, 2 at position 1, so it's here, 1, 2, 3, and then 1 at position 0, so it's like this. Okay. Yeah. Yeah, this is how the lookup table should be generated. And then what do we do with this? We should just be able to iterate through, find the furthest, and repeat what we were doing over here, right? This is just for the lookup table generation, which should just be, we start with the second to last row, all the way down to -1, we go down by 1. Okay, there's no n, it's len s. And then how do we do this? We just copy the row, we copy this row, and then we update one value, right? So we can just do next pause. Oh, we have to, for in range 10. No. Can I just do, our current row is next pause I. Next pause. Right? Well, we can't do this. We have to reassign everything, right? Because this will make them point to like the same point in memory or some shit. It's gonna fuck things up. Right, I don't think we can do, I think we just still need to loop through for I in, for J in range 10. There's 10 digits. Next pause. I, J is equal to next pause I plus 1 j, and then our current digit is equal to int si, right? Let me think. Int current digit, and then yes, and then our next pause I digit should be equal to our current index. Print next pause. Okay, so if I run this on, did I kill my 1, 2, 3, 4, 5, 6 case? If I run this, I should get something that looks like this. It's over. End of file when reading line. Test cases. Like this. Then super, then S. -1, 0. 1, 2, 3, 4, 5. -1, -1. Okay. This is best case we can get. This is -1 down the line. 0 and then -1 down the line. 1, 1, -1, 2, 2, 2, 3, 3, 3, 3, 4, 4, 4, 4, 4, 5, 5, 5, 5, 5, and then all the rest. Okay, I think this is working. Now, what we need to do, our current index, 0, and then is possible. Set it to false. Then for I in range, im, our farthest is -1. Cap it at int ri, increment, it's ri plus 1 and our increment is normal. Our next equals next pause cur J, because J is our do I need cur? Can I just use I? No, because cur, we have this extra one. Just okay, this should be right. And then I just check if next is equal to -1. If it is, then possible set to true, and we break. Then we check if possible, if break, then should put us out. In the for loop, if is possible, yes. Then not done yet. Need to check. What is this? Farthest. Jesus. And next. Right. No. Fuck. What is going on? It's okay. Seems to be working. Farthest for J. Look through. cur is 0. So we're at 0. Or look for J. So 5. Look at 5. 0, 1, 2, 3, 4, 5 is 4. So next. Right, that's correct. Then next not. So we go here, farthest equals max -1 and 4, which is 4. Farthest plus 1. Or cur plus 1 is 5. So now we'll go to the next digit. From 0 to 6. Cur is 5. So looking at everything after 0, 1, 2, 3, 4, 5. Looking at all of this. And then Li is 0. Wait. Cur is 5. We're not looking at this. We're looking at 1, 2, 3, 4, 5. Starting from 0 through 6. 0, 1, 2, 3, 4, 5, 6. Right, and since the first one's -1, just break and print. Okay, yeah, I think this is working. I'm a little bit worried about time complexity. But it should be is 10 m. Let's get rid of all the print statements first. This one should be digits, so m, the length of s. Three times 10 to the 5th. It's the length of s times 10. So this part is something like this. Should be fast enough. Yeah. Okay, we got it. I'm gonna call it here. Damn, this question was hard. Definitely need to bookmark it. If Codeforces loads. Here it is. Alright, if y'all enjoyed this video, be sure to like and subscribe. Join the Discord. I would love to have y'all there. If y'all have any questions or comments, leave them down below. I respond to everything. And I'll see y'all guys next time. Bye.